Your water KPI can be 100% accurate and still completely misleading. And not because the number's wrong, because nobody stated what it's measuring, against what baseline, or in what basin. Withdrawal, consumption, and discharge get quoted like they're the same figure. They are not. And a 10,000 cubic meter number means something completely different in a water-stressed basin than it does anywhere else. That gap, the missing baseline, the missing boundary, the missing context, is where most site water reporting quietly falls apart. Let's define the term properly. A water KPI tracks withdrawal, consumption, or discharge. 3 distinct volumes, and they are not interchangeable. Quote the wrong one, and the number you report is technically true and practically meaningless. It's also meaningless without a stated boundary. Site level, facility level, or organization level. Pick one and say so in the report. Baseline means something specific too. A defined 12-month reference period, the one every future target gets measured against. Not last year, roughly. 12 consecutive months, named. And stewardship implies context. The same 10,000 cubic meter withdrawal reads completely differently in a water-stressed basin than it does anywhere else on Earth. Put it together, and the standard here is GRI 303, Water and Effluents. A KPI without a named baseline period and boundary is not a KPI. It's a snapshot.
4 frameworks, and they each do a different job. Practitioners routinely reach for the wrong one. GRI 303 is the disclosure standard. It standardizes how organizations report water impacts, what you actually put in the report, clauses 3031 through 3035. UN SDG 6.4 is the policy anchor, indicator 6.4.2 specifically, withdrawal measured against available resources, used to set measurable targets for water use efficiency. CDP Water Security is the investor questionnaire. You disclose water risks, strategies, and performance to investors, and it's usually customer or investor triggered rather than automatically mandatory. And the AWS standard, Audit Water Standard, is site certification, verified independently across 5 outcome areas. So, report with GRI, target with SDG 6.4, disclose through CDP, certify with AWS.
Here's the actual definition, because most people use this term without ever seeing the number behind it. Baseline water stress, BWS, is annual withdrawals divided by long-term renewable supply, scored per basin. WRI Aqueduct's Water Risk Atlas scores it on a 5-band scale. Low, under 10%. Low medium, 10 to 20. Medium high, 20 to 40. High, 40 to 80. Extremely high, above 80%. GRI 303 sets its own reporting trigger right at the high band, a BWS ratio of 40% or above. GRI accepts either WRI Aqueduct or the WWF water risk filter as the tool. Pick one and disclose which one you used. Most GCC basins sit in the high or extremely high band. That context isn't optional, and it isn't a special case that needs flagging. On this region's projects, it's the default. 3 terms practitioners confuse constantly, and this is the equation that trips up more reports than any other single mistake. Withdrawal is water drawn from any source at all, surface, ground, seawater, produced, or third-party water. That's the total volume taken. Discharge is the returned portion, water released back to a source, by destination at a stated quality. Consumption is the not returned portion, evaporated, incorporated into product, or moved to a different watershed entirely. Put those together. Consumption equals withdrawal minus discharge. That's GRI 303-5. Get that equation wrong, and every downstream number, your target, your intensity ratio, your CDP submission, is wrong along with it. Every liter counted starts here. A groundwater abstraction wellhead, The exact point where a water KPI either starts out accurate or starts out wrong. Picture a large earthworks package on a GCC mega project. 3 water sources on one site: desalinated supply, groundwater dewatering, and TSE reuse. The environmental team has 12 months of meter data, but it's in 3 different formats from 3 different subcontractors, none of whom coordinated with each other before submitting it. Head office needs one defensible baseline number by Friday for the annual ESG report, not a range, one number. This is exactly where most sites either build a real baseline or quietly guess one and hope nobody asks how it was calculated. Here's the 5-step process that closes that gap. Step 1. Establish the baseline. Use 12 consecutive months of metered data, not estimated, not a partial season stretched to look like a year. Characterize every source separately: potable, desalinated seawater, groundwater well, rainwater, TSE. Classify each one by its GRI 3033 category before you total anything. Totaling first and classifying after is how sources go missing. A dewatering pump left off the meter schedule is without question the most common baseline gap on site. It's temporary, it's often subcontracted, and it's exactly the volume that gets forgotten. Lock the baseline period in writing. Every future target you set gets measured against this one number. Step 2. Map the water stress context. Run every single site location through WRI Aqueduct or the WWF water risk filter. Not a head office guess, not "we know this region is dry." Record the basin's BWS band against each source location individually. A site sitting in the high or extremely high band carries a materially different reporting obligation than one that doesn't, and on a large footprint, different sources can land in different bands. This step is what turns a raw withdrawal number into a risk-weighted one. Document the tool you used and the date you ran the assessment. Auditors ask for both, and "we assumed" is not an answer either one accepts. Step 3. Set a context-based target. Skip the flat percentage reduction target. A 10% cut means nothing without basin context, and a target that ignores context is a target that can't be defended under review. Use SBTN's Step 3 freshwater guidance to size it against the basin's actual sustainable water balance instead. Targets can be quantity-based, withdrawal or consumption limits, or quality-based, tied to pollutant load. AWS certification is also a valid target format, specifically for a single high-risk site rather than a portfolio. Notice the order here. A target set before Step 2's stress mapping is a target set on a guess, no matter how precise the percentage looks. Step 4. The 5 GRI 303 disclosures. This is the checklist itself, so take it clause by clause. 3031. Your interactions with water as a shared resource, by catchment, including stakeholder engagement. 3032. The effluent quality standards you apply, even in locations with no local discharge limit at all. 3033. Total withdrawal in megaliters, by source, split between freshwater and other water at or below 1,000 milligrams per liter TDS. 3034. Total discharge in megaliters, by destination and quality, including any non-compliance incidents during the reporting period. And 3035. Total consumption, calculated as withdrawal minus discharge, broken out specifically for water-stressed areas. That's the same equation from slide 5, now written into the disclosure standard itself. Step 5. Integrate into ESG reporting. GRI 303 feeds your sustainability report directly. CDP Water Security repackages that same underlying data for investors. Now, a live regulatory detail, so pay attention here. CSRD's ESRS E3 was simplified by the European Commission on the 3rd of July 2026, and it's still in EU scrutiny as of this recording.
That simplification drops the mandatory water intensity ratio. It applies from financial year 2027 and is optional for 2026. Until it's fully in force, confirm which ESRS E3 data point set your specific reporting year actually needs. Don't assume last year's requirement still applies. One data set, 3 formats. GRI for the sustainability report, CDP for investors, ESRS E3 for CSRD scope.
What leaves the site still counts. A discharge point isn't the end of the water KPI. It's the second half, and it's where the next mistakes live. Edge case 1, withdrawal-only reporting. The error? Reporting potable withdrawal and leaving dewatering volume off the KPI entirely, usually because it's temporary, subcontracted, and nobody assigned it an owner. On earthworks packages specifically, uncounted dewatering can exceed the counted potable supply several times over. GRI 303-3 requires all source categories, without exception. Dewatering is its own line, not a footnote at the bottom of the report. The fix? Put every extraction point on site, including temporary dewatering, on the same meter schedule as everything else. Edge case 2, the stress-blind target. The error, applying the same flat reduction percentage to every site in a portfolio, regardless of water stress. A 10% cut in a low-stress basin and the identical cut in an extremely high-stress basin are not equivalent reductions. They don't carry the same risk, and they shouldn't carry the same weight in a report. Under CSRD's double materiality lens, treating them as equal reads as an impact materiality miss. The fix, and it's the same discipline from Step 2 and Step 3, run the basin mapping before the target setting, never the reverse. Edge case 3, the return to source fallacy. The error, treating dewatered groundwater discharged to a wadi as return to source. It isn't, and this is the most common good faith mistake of the 3. Under GRI, consumption equals withdrawal minus discharge, only when the water is genuinely not incorporated or degraded in the process. IFC's Table 1.3.1 limits, pH 6 to 9, TSS at or below 50 milligrams per liter, cover sanitary sewage only. Assuming those same limits govern dewatering discharge is itself a separate and very common error. The fix, reference the local permit, or an analogous sector guideline if no permit exists, then report the discharge by quality under 3034, not as an automatic return to source. So, 5 things to check before you calculate anything on your own site. 1. Lock a 12-month baseline, source by source, before you total a single figure. 2. Run every site through WRI Aqueduct or the WWF water risk filter and record the BWS band against each source. 3. Set targets against basin context with SBTN freshwater, never a flat percentage applied portfolio-wide. 4. Map your data to all 5 GRI 303 disclosures. Withdrawal, discharge, and consumption are not interchangeable, and each one needs its own line. And 5. Confirm which CSRD ESRS E3 version applies to your specific reporting year. The simplified standard is still in EU scrutiny, and last year's rule is not a safe assumption anymore. If that was useful, subscribe. Site-based environmental and sustainability training every week. Next in this playlist, building a sustainability KPI dashboard from scratch. And if you missed it, the previous video covered carbon footprint reduction strategies on active construction sites.